Hello, today we are going to present our topic polarization of light and its application. How do we think that the light travels in one direction or in many directions? Actually, normal light travels in many directions, that is called as the unpolarized light. We can see here that this arrow passes in a different direction. This is unpolarized light. Now, what happens when we want a light to be traveled in one direction? When we pass the light through a special filter called as a polarizer, we can get the unpolarized light to be converted into polarized light, and this phenomenon of light conversion is nothing but the polarization of light. In simple way, we can say that the conversion of unpolarized light into a polarized light is called as the polarization of light. Now, the next part of our presentation will be explained by the Yash, that is the application of polarization of light.
Thank you, Govind, for giving us the information of correlation of light and overview of correlation of light. Now, I will be talking about the two laws and their application. The law that is Brewster's law. What's Brewster's law tell us? So, Brewster's law is simply when an unpolarized light if you see the diagram here, the unpurged light that is coming from the medium of air, that is N1, is coming and it gets hit in the surface. When it hits the surface at an angle of theta b, this angle has to be maintained. Angle is called as Brewster's angle. When it hits the surface, it gets it splits into two rays. One is reflected ray and other is refracted ray. The reflected ray is a fully polarized rays, and the refracted ray is slightly polarized rays. So the reflected ray we visible it is visible to us in various situations. We see it day to day life also. So let's talk it now. So that's are the application of Brewster's law. So first, road surface. Road surface reflects polarized light, creates driving glare. So just when you drive a car, the fire surface of a road, it appears as like a water or something uh, like a brightness of light at that place. When we come near to the road, that road it gets away. So it's simply the angle from which the light or that is sunlight comes from the air. When it hits this road, it gets split into two, and this porous part is visible to us. And as we come near, it gets out. So for this, porous sunglasses are used here. So it's also used in ships where we have to see the faraway places. So polarized lights are sunglasses are also used for such process. So it is also visible here. So what's the difference? Non-polarized here we can see the sun glare, the sunlight glare. So non-polarized light it appears as and the view is not correct. So in the polarized lens, we can easily see the faraway objects without any glare. Has it reduced the glare? So for this purpose, polarized sunglasses are used. Nowadays, camera polarizing filters are also used. So what's it basically? It tries to remove or reduce the glare from the image automatically and gives us a clear image without any glare. So it helps a lot. So let's now discuss about the second law that is also important. That is Malus law. So Malus law is simply it controls the intensity. So this law helps us to control the intensity of polarized light. It depends on angle between the polarizer. So there are polarizer and the angle between them depends the intensity of the light. So the equation of Malus law is I equals to I zero cos square theta. So here I zero is the initial intensity and theta is the angle between the two polarizers. So this angle is important has it controls the intensity of light. Let's assume that if the angle between the two polarizers is 0 degree, then the light passing will be maximum. Then the I0 light will be passing uh, to the output also. So if it's 45 degree, then I0 will be half. Then the light will be half. So if the angle between the polarizer is 90 degree, then the light intensity of light will be zero. There will be no light passing through that polarizer. So now let's talk about the application of Maler's law. So Maler's laws are used in polarized sunglasses. We discussed before that it is used to reduce the glare and control the light intensity. LCD screens. So LCD screens we observe it in mobile phones and laptops and various TVs, various electronic devices. So in it there's brightness, there's screen, and to control the intensity at that moment we need an polarizer in it. So in the image it is visible that there are two polarizers. The one at the front, at the last, and the green one in the front. So these two polarizers helps to control the light in the computer, and in it is similar concepts are used in various other electronic devices also. So yeah, LCD screen also uses polarizing to control the intensity of light and to enhance our viewing experience. And these are the daily life use of Maler's law. And now we will just discuss the application in space telescopes. So various space telescopes use polarization of light to know information beyond the various distance and beyond the images. So one of the example is XPOSat, X-ray polarimetry satellite. So it's made by ISRO. So it's basically gets the basically studies the polarized X-ray. It studies the polarized X-ray. It helps to detect the magnetic field structure of objects beyond various galaxies or universe. Used to study black holes, neutron stars. So it polarization gives hidden information beyond images. So XPOSat is nothing but it gives the information, hidden information beyond images. So an image cannot give us the exact information has an polarization of light can give us. It is images help us to only uh, view the view this galaxy, view the objects, but the polarization helps us to study in depth. So this concept of polarization of light are used in space telescopes also. So now I will tell Sahil to explain and summarize the topic.
Thank you, Yash. Now I will summarize our topic. Polarization of light is a phenomenon in which vibration of light waves are restricted to only one particular direction. As we studied of Malus and Brewster's law and its application in real life. It is used in telescope like ExoSat. We discussed it. It helps us study magnetic fields and structures. It also used in daily life like sunglasses, LCD screens, and more such applications. For reference, we use ISRO and NASA websites and some physics books. Thank you all for listening our presentation.